Hey everyone, today we'll be solving house robber problem from the Neetcode list. Okay, hopefully this is visible. Let's see what the problem statement is saying and let's start the timer. Okay, you are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have a security system connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. Given an integer array nums representing the amount of money of each house, return the maximum amount of money you can grab tonight without alerting the police. Okay, given an integer array nums representing the amount of money each house, return the maximum amount of money you can grab tonight without alerting the police. Okay, so let's see the example. 1, 2, 3, 1. Okay, 1, 2, 3, 1 are the houses, and the total count is 4. So which house did they take? 1 and 3 they took, right? Okay, rob house 1 and then rob house 3, money equal to total total amount you can rob is 1 plus 3 is equal to 4. Okay, so given an integer array nums representing the amount of money each house, return the maximum amount of money you can grab tonight. Got it. And 7931, rob house 1, money 2, then 3, 9, rob house 5, money 1. So 2 plus 9 plus 1, 12. So if you see the brute force approach of doing this, then it's pretty weird. Like my thought process is like we can we can take the house first or not take the house first, right? We can take the second house, but if we take the first house, we cannot take the second one. We have to take the third one. Okay, how will you solve it with the help of so it's a dynamic programming problem. So how will I solve this? Mm-hmm. So first I'm thinking, uh, can we use recursion? But using recursion will simply make things weird for us. Okay, let me open up the Google Keep. Wait a minute, I'll take this here. Google Keep. I just want to open the Blackboard that I was using yesterday. Okay, let me bring that page here and let's see if we can do something about it. Um, wherever we house robber, right? So if I come here, then 1, 2, 3, 1 is one example, and then 2, 7, 9. So let's keep one example for now. And okay, so 1, 2, 3, 1 is there. So what we can do is we can always select first house whether to go with or not. So 0, 1, 2, 3. If we go with it, then we have to consider this, and then we have to somehow skip this guy, and then take the next one until we reach the end of the. So if I take one, let's say we take one, and then okay, we are on 0. So either I have to take it or leave it. If I take it, let's say take it, then I have to go to 2, index 2, and here also either take it or leave it. If I take it, then I have to continuously also count my um, my robbery money. So 1, I pass this 1 to this, so this will become 4, and I also need to check if so clearly I cannot take the second one, so I come onto the null, so this gets returned back, 4 gets returned back, so 4 is returned on this guy. Okay, and now if I decide not to take it, then what happens? If I don't take it at all, then I can go with 2, sorry 1, and then here there are two options. I can take one, or if I take one, then I cannot. So here 2, then I have to take 3, and this 3 make this 4, and it reaches null. Okay, yeah, and we have to also do this for this guy. If we don't take this, then 1 comes. And this becomes 2. Then we have to return back what is the maximum out of this 2. Okay, so at every step, what I've identified is like we have to either consider taking the like we will be looping through the entire houses, and at every step, like we'll be doing this for every house. We'll go here, and then we'll check if we can move forward or not, and finally we'll return maximum houses that we can reach from this node, and then we have to do the same for this guy, and do the same for this guy and this guy. Um, but at a certain point, we might be repeating our steps. So, or we won't be. Um, let's say we don't add anything, and we go on to the till the end of the this thing, and then we start sending back whatever value we have. Like we'll send 3 back and so on and so forth. Okay, let's so this is the purely brute force approach. Like this is not dynamic programming, but a brute force approach. Let's try to implement that. So anyways, we have to for let house of nums, we have to do a DFS of house, and what we need to do is, okay, so let max profit is equal to, and nums of I is 0, right? Let's say minus 1, because the value would be greater than or equal to 0 and between 400. So yeah, we can do this. Let max profit and DFS and max profit is equal to math.max, and we do this. Okay, yeah, so we are finding out what maximum probability that we can do if we select the house 1. Then we are comparing it with our max profit and storing this, and then finally we can return this max profit. Okay, so this is where it gets interesting. We have to do it DFS, right? So let's write a function DFS which takes in the house number, and what we do here is we have the axis of nums. So if, okay, here we are not getting the house number, but instead we are getting the actual value. So I is equal to 0, I is less than nums dot length and I plus plus. So we send here num, sorry, we send here I, and first of all we have two conditions, either to take the house or leave the house. Okay, so we have these two conditions. Now what we can do is, so I'm thinking if we reach, suppose the house number that we are on is greater than equal to nums dot length. If say we reach this point, then we should be returning something back um, to our house. So what it should be, if we reach, let's say here, return 0. will be returning back 0. Okay, so if we take this house, then let rob house is equal to, we need to definitely consider the value of it, right? If we are considering this house to be taken, then house, sorry, nums of I plus whatever we send from here should be returned back, right? So DFS, what we'll do is we will send if we consider robbing this house, then definitely we need to send the next house like +2, not +1 but +2. So we'll go to the next house and I take the current house and jump, okay, jump to jump to second adjacent house, right? So yeah, we do this, or if let leave house, if we let's say not rob this house at all, then we simply do DFS nums of I plus 1, right? Is that right? Yeah, that is right. So once we do that, what um, what we need to check is return math.max of rob house or leave house. So once we do that, we'll okay. So I think I should try run this because I'm not sure if the I'm doing it correctly. Okay, so how much time? 18 minutes. We are into this 18 minutes. So yeah, let me just do this and let's go to, so what we are doing here is num of I plus DFS num of I plus 2 or BFS of nums of I plus 1. Okay, and let's jump here. Okay, we are doing this two operations. So we send 0 first. So 0 comes in, 0, 0 comes in, 0 comes in, then we decide to take 0 as is, and then 0 value is 1, and then we um, wait for the answer to be returned back, right? Then we go to the third one, the um, second index, because we don't have to take take this guy, we need to take second index, which is this guy. And once we take that, then again we have to decide whether to take it or not. So we decide to take it. Um, and we do 2 plus a, a box where it is expecting a value. Then what we do is jump. So once we jump, the value of second index would be 2, right? 4. So 4 is obviously greater than equal to nums. So we return back 0. So this is 0 is returned. So 2 plus 0 is 2. So we have 2 in our hand here. Then we have to check this condition, right? This condition where we leave the 2. Um, then here we just go ahead with, we don't take 2 at all, but we take the next element, which would be 3, which would be index 3. And here we take this index, and here it will be waiting for another. So here we have to jump to the next one, which will be 5, which is obviously greater. Then we'll return 0. So once we return 0, this guy has this, and then we have to also check it if we leave this guy. We don't do anything, which will be 4 in that case, which will be again, so this is 0. So what we have to do is send maximum of these two value, which will be obviously 1. So this guy will send 1. So now we have these two values, which will be 2 will be returned. So 2 plus 1 is 3. Okay, so I have oh sorry. So it was 3 here, not my bad. It was just 3 here. Why is this error coming? And yeah, let me correct it. So here it is 3. So here we send 3, 3 plus 1 is 4. So finally we'll be returning. So here 4 is there, and now we have to check if we leave. Why is this error coming again and again? So now we have to check whether this guy, if we leave this guy, then we will be selecting. Let me refresh this and let's see if, why is this error coming in again and again? Okay, to give you guys recap, if there was some kind of error or bug, we have 3 here, so we send the maximum 3, so this becomes 4 after calculating. Okay, so why do I keep getting this error? Okay. I know, it's okay. Save. I've saved this file, man. Come on, give me a break. I thought this one is good, but this error is randomly popping up. I guess there is some bug in their Excel draw. I was starting liking this, but okay, we I guess we have to jump back to the Miro board and leave this. Miro is also kind of it behaves weirdly. Let's see, where are we? Okay, okay, okay. So we have this guy. Let's rub this out and let's get the pen. So we had this 1, 2, 3, and 1, right? So 0, 1, 2, 3, and we started our journey with 0. Um, and then we kind of this left was like taking the 0, and then the second index, and then we finally reached 4, which is greater than equal to num. So we send 0, 0 back, which 3 plus 0, and then we did it for 1. If we take 1, then this was 5, which is end of 0, then 1 plus 0, and this is also end, so 0. We send 1 here, then 3 is greater, then we send 1 plus 3, which is 4. Now we have to check for 2, we send 2. Okay, what we can do also, that we can also, so there is a redundant work that is going on here. If we select 2, then the, okay, yeah. Sorry. We have to select 1 here. 1, I mean 1. If we don't, then 1 here, I mean 3, index 3. So these are all indexes. These are all indexes. So I'm sorry if I confused you guys, but these are all indexes. Then we take 1, then we have to take third index. So if this is clear, then we can get rid of this. Then once we take 3, um, third index, then we have to jump, right? Jump to 5, which is greater, add 2 and jump to index 5, which is greater than the nums. Then we send 0. Here 1 plus 0, here we send 0 back. And then if we kind of skip this 3, not take it, then it was, but wait a minute, I'm really sorry. Okay, let's do one thing just to see if the work is that the work that we are doing is getting repeated. I think we should keep this as is. Then one. Then let's go to the next one, which it will be the third index, and the third will jump to 5, right? This should be 4, which is greater than, this will be 5, which is greater than. So here we are always sending 1, and here we are always sending 4. So here 0 and 1. So what we can do is that we can then starting to store in a cache. We can also use a cache for us to store these value, right? Okay, so let's say if cache dot has um, house num, then we simply return, sorry, my bad, some messages are popping up. Okay, yeah, we can simply return that cache dot get house num, and okay, so we also need to declare let cache, if I can spell cache, new map. So here we have created a cache, and then what we do is cache dot set house num, and we simply copy these two guys and set it here, and we got a cache dot get house num, right? That's what we can do here, right? So yeah, let's go back to the Miro board, and here once so if we have cache, then it will directly send 1 to this guy, and one index as 2, so 2 plus 1 will be added, and if we skip 1, then we can go to go to 2, and so on and so forth. 2 plus, okay, this, okay, you get the idea, right? So we so okay, let's do one thing. Let's complete this whole thing. So we if we try to skip the the first index, then definitely we have to take the second one, right? So 2. So as 2 has 3, this will send 3 here. Let me change. Here we have already encountered 3, so we can send 3 back. So 3 is sent. So this is again 3, so anything can go. So yeah, 3. So this is definitely greater. So okay, and then we do it for 2, but we'll get the 2 value again itself, which would be, sorry, first index, which would be 3. Um, yeah, if you see, if we take index this house, we can only take these two values, so it is 3. So we will be returning 3. Okay, there is some repetitive work that is going on. I guess this code should work. And then finally, whatever is returned, we are storing it here. And then, yeah. Okay, fingers crossed. And let's do this. Okay, nums of I is not defined. Oh, am I doing I here? Can I? Okay, let's do it. House num, house num, house num. Okay, got it. So that's good. Okay, then if we run this now, nums, sorry, my bad. Nums, here also nums. Is there anything else remain? Okay, no. If house num is greater than equal to nums dot length, oh, okay, my bad. So we don't have to do this because, okay, yeah, sorry, my bad. Okay, yeah, that's all that case. Okay, so let's submit. Oh, yes, got it. Okay, so yep, the basic idea was to cache. So yeah, it looks like it's not that efficient, and every time we are making decisions, so it's the time complexity of DFS would be 2 raised to n, because at every node we are taking two, we are either selecting it or not selecting it. So at every node we are making two decision endpoints, and if you see, we are going till the end. So this will be yn because the height of the tree is n. So for every node we are making two decisions, so 2 raised to n would be the time complexity of this algorithm. And yeah, so n is constant at this point, and cache would be O of n because we are storing the value, the maximum value in there. So that's that. Let's try to see like how we can solve it with the help of let's see how we can solve it with the help of dynamic programming in the later video. But yeah, that's about it. Or you know what, we can still continue this and see how it goes. So have I solved this anytime? Okay, yeah, I did solve it earlier. Okay, so August 2022, I solved this house number, and I solved it today. After that, okay, yeah.